So this unit is about similar triangles, and before we get to the bulk of what similar triangles are and how we go about solving them, we have to have a refresher on ratios and proportions. So that's the first thing we're going to do here. And what is the definition of a ratio? Remember, it is a comparison of two quantities. And the biggest ratio that we dealt with last year was slope. Remember, it compared change over y over change over x. So that's exactly what a ratio is. It's a comparing two numbers. How do you represent a ratio? Well, you can use like 2 to 1, using the word 2. You can use 2:1, or you can use 2 over 1. Typically, we use ratios in math as it looks like a fraction. And of course, ratios not only can be, but need to be simplified. Always, always, always give me a simplified ratio. So just to remember how to do them, we're going to go over the odd examples together. If a music store has 40 trumpets, 39 clarinets, 24 violins, 51 flutes, and 16 trombones, write each ratio in simplest form. So if we compare trumpets to violin, we have 40 trumpets and we have 24 violins. So it would be a 40 to 24 comparison. However, you wouldn't give it to me like that. You have to simplify. So it would be a 5 to 3 ratio. Okay? So a 5 to 3 ratio, 8 goes in those both times. If I want to compare trombones to trumpets, remember, order does matter. You do trombones first, we have 16, and then trumpets, we have 40. So if you have 16 over 40, you would have 4/10, but that could also be reduced to 2/5. 8 goes into both of those as well, and we simplify the lowest we can to be 2/5. When we talk about extended ratios, we didn't get into a lot of that last year, but extended ratios, it's a comparison of three or more quantities. And extended ratios are written specifically with colons. So you have A to B to C. We wouldn't do it as a fraction because you can't have a fraction over a fraction. So let me move my screen up and then we will go over examples of these. We will be doing extended ratios a lot with similar triangles. So we know if you have a ratio of two complementary angles is 3 to 7. That's the proportion of complementary angles. So what do we know about complementary angles? We know they add up to 90. And they are in the proportion of 3:7. So if I know that this angle and this angle all equals 90 because it's a proportion of 3 to 7. So both of those angles add up to 90. So I get 10x equals 90. X then equals 9. So if I want to find the measures of both of those, this angle is going to be 27 degrees, and this angle, of course, would be 63 degrees. And they match that 3 to 7 proportion. They both add up to 90, so I know that that's the correct answer. If you look down here and we have the ratio of measures of angles in a triangle, we know that there are 180 degrees in a triangle. So if they fit this proportion, 4, 7, 9, I'm going to do 4x plus 7x plus 9x all equals 180. And when I add those together, I get 20x equals 180. Divide both sides by 20, and I get x equals 9. So if I want to find out what these angle measurements are, of course I would do 4 times 9 is 36 degrees, 63 degrees, and 81 degrees. And those all add up to 180. So that's how I would find the extended ratio of those measurements. Let's look on the other side. So flip over your notes to the other side and let's take a look at number 9. So here, we're still doing an extended ratio of 2 and 8 and 9, but now we're looking for perimeter. So make sure you read what the question's asking. So we know perimeter, you add up all the sides. So it's going to be 2x plus 8x plus 9x, and all of that equals 76. That's the perimeter of my figure. So again, we do 19x equals 76, and when I divide both sides by 19, I'm going to get that x equals 4. So when I find the lengths, of course I just plug back in x, and I get 8 inches. We know the units is inches, so 8 inches, 32 inches, and 36 inches. And of course I would want to make sure that that all equals 76 degrees, so 68 and 8, that is 76, so that is my correct answer. So make a note, circle, highlight extended ratios, but we will be using those frequently. Okay, so the next one, this is straight out of a review from last year, but what is a proportion? A proportion is an equation, and what does an equation have? Well, it has an equal sign. That's what makes it an equation. It's an equation that states two ratios are equal. And a proportion is written as A over B equals C over D. Here's my equality. One proportion is set equal to another proportion. And last year, remember how we solved proportions? We cross-multiplied them. And so that was our cross-product property. Cross-product, product means multiplication. And so how would I do that for any proportion? I would say that AD, the product of AD, equals the product of CB. That's how I make that proportion. Quickly, we're going to solve a few of these. Again, this is just a refresher from last year. So if I set up those proportions, mainly I want to go through numbers like 15 on down. So if I look at number 11 and I cross products, I would say 2x equals 28. Divide both sides by x, and I get x equals 14, and I box my answer. Remember in algebra, we said the first step to solving proportions is to put parentheses around your binomial. So on 13, there's my binomial. Why do I do that? I do that because I need to remember that I've got to use the distributive property. So when I cross multiply, I'm multiplying 19 times x minus 1 and setting that equal to 6 times 3, which is 78. So now I have to use the distributive property, and I get 19x minus 19 equals 78. Don't forget to distribute. Add 19 to both sides, and I get 19x equals 157. And when I divide both sides by 19, I'm going to get x equals 5.1. That's 157. No, it's not. 78 plus 19 is not 157. What am I doing? Even if I 97. Whew, I was way off. And then I would get 5.1 is my answer on number 13. Okay, let's jump down to 17 and 19. So here I'm going to put parentheses around my binomials, and I'm going to cross multiply. Again, it doesn't matter the order. So 3 times x minus 11 equals 18 times x minus 20. Don't forget to distribute, so I get 3x minus 33 equals 18x minus 360. I bring my variable terms together. Again, it doesn't matter the order in which I do that. So I'm going to bring my variables to the left. And I get negative 15x minus 33 equals negative 360. Then I add 33 to both sides, and I get negative 15x equals negative 327. And when I divide both sides by a negative 15, I get negative divided by a negative is a positive, and when I use my calculator, I find that it is 21.8. So x is going to be equal to 21.8. I know I went through that quickly, but remember these are rules from algebra. Distribute, simplify, variable on one side, constant term on the right, and then we divide. Okay, let's take a look at number 19. Okay, 19 we did towards the end of last year, and remember you guys were in quarantine, so I really want to look at number 19. Okay, When you multiply x minus 1 times x plus 5, again, it's a binomial times a binomial, and then I set that equal to 5 times 27, and 5 times 27 is 135. I expect you guys to be in tutoring if you do not remember how to do this. The FOIL method where we did first, outer, inner, last. So we did first terms, x times x is x squared, x times 5 is 5x. Then I did my inner terms, negative 1 times x is negative x, negative 1 times 5 is negative 5, and I set that equal to 135. I combine my like terms, and I get x squared plus 4x minus 5 equals 135. I know that this is a quadratic term, so I set everything equal to 0. So I'm going to subtract 135, and I get x squared plus 4x minus 140, and I set that equal to 0. At the end of last year, we talked about factoring quadratic terms. Here it is. You're going to see it in geometry. So if we need to go over it in class for a little bit, you need to tell me. If you want to come into tutoring, I can give you problems and we need to work on this. But this is where Algebra 2 picks up. So make sure your skills are sharp. So when you have something like this, remember when we factored, this is a basic trinomial. So 1 is in front of x, so I do 1 times negative 140, and I get negative 140. Now I'm looking for two numbers that when multiplied together give me a negative 140, but add to give me this positive 4. So you can go through the list. Negative 1, 140, negative 140, and 1. You know it's not going to be somewhere around there. I know 10 and 14. So if I have negative 10 and 4, not negative 10 and 14, negative 10 and 14, that's going to be a positive 4. So negative 10 and 14 are a positive 4. You've got to get your signs correct because a positive 10 and a negative 14 would produce a negative 4. But I need a positive 4. So it's negative 10 and 14. So watch what I do. X plus 14, x minus 10, and I set all that equal to 0. I'm solving for x. So what do? I take each factored binomial and set it equal to 0. And I solve. So x equals negative 14 and x equals 10. There's two solutions, so I write x equals negative 14, comma 10. And that is my answer. Highlight number 19 and ask me or tell me, do we need to review this in algebra or did you want to come see me for tutoring? Or if you remember, great, we don't need to work on it. Up to you. Let me know. Good luck.